Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it's time to continue further with Mathematics class 12th, and the chapter that will be starting today is integrals, the big chapter of integrals, which contains questions from indefinite integration and definite integration both. Right, this particular chapter has both of these chapters clubbed together, and yes, it is the longest chapter that you have. So today is the turn of exercise number 7.1, and what will be involved in this particular exercise. So we'll be solving some questions based on the standard formulae, the basic standard formulae which have been directly derived from the concepts of differentiation, right? Indefinite integration is actually reverse anti-differentiation or reverse process of differentiation, right? On the basis of that, there are some formulae on the basis of which we'll see some questions here, right? Formulae like integral of, for example, polynomial functions, integral of trigonometric functions, simple, right? Some standard, right? Integral of sin x, integral of cos x, integral of sec x tan x, integral of cosec x cot x, integral of sec square x, integral of cosec square x. That is what we'll be dealing with over here. Then inverse trigonometric functions as well. Integral of 1 upon root of 1 minus x square. That's something which will be there. Integral of e power x will also be here, right? So formulae related to this and questions based on those, along with some basic, let us say, theorems of integration, that is integral of fx plus gx is equal to integral of fx plus integral of gx, right? There are no methods of integration involved over here in this exercise, direct results are involved, and we'll be seeing questions. Along with the questions, we'll also see the concepts wherever required, and let's begin with the first question over here. The question says, find an antiderivative or integral of the following functions by the method of inspection. Okay, so method of inspection says that we have sin 2x. Okay, sin 2x could have come by taking derivative of something called cos 2x, right? So we'll be dealing with the method of inspection. I'm not dealing with any formula right now, as the person says that we have to inspect. So we just have to inspect. Although if you have studied integration, you would realize that sin 2x integral is not very difficult thing. But then by inspection, it says, okay, sin 2x should have come somewhere from cos 2x, because the derivative of cos x is minus sin x, right? So derivative of cos 2x is sin 2x with a minus, and there is a derivative of 2 as well, which is 2x, which is 2. So this is what you'll be getting. Derivative of cos 2x is minus 2 sin 2x. This is what you have, right? And if you want to find the integral of this, can we take this minus 2 over here? Yes. What will we get is minus 1 by 2 d by dx of cos 2x is equal to sin 2x. Okay. And this minus half can go inside this derivative without affecting anything, right? This is a constant, so this becomes minus half cos 2x. This is what you get, right? Which is equal to sin 2x. Okay, that's pretty interesting. And once you have reached this stage, do you see that now I can write, therefore, integral of sin 2x with respect to x. Integral of sin 2x with respect to x is simply minus 1 by 2 cos 2x. That is the required answer for this particular question over here. Yes. By inspection, we have seen, okay, derivative of cos 2x is this. Therefore, let's try to create a sin 2x on this right hand side, and on the basis of that, after integrating this, we get this particular thing. That's the final answer for this first question. Question 2 says that we have to find the integral of this antiderivative or integral of this by inspection. Okay, so once again, for cos 3x, the first thing that comes to mind is that the derivative of sin x is cos x, therefore derivative of sin 3x will be somewhat in terms of this, right? So let's begin with the derivative of sin 3x. What is that equal to? Now sin 3x, the derivative will be cos 3x, and since we'll have to apply the chain rule, 3x will have to be differentiated, and that derivative is equal to this 3 times cos 3x, right? Okay, and now I'm interested in only this one. Okay, so let's bring that 3 over here, and where does that take me? D by dx of 1 by 3 over here, or which can be brought inside, and this can be written as this, right? that constant outside can be brought inside of the derivative without affecting anything, right? And this is equal to cos 3x, okay? Since d by dx of 1 by 3 sin 3x is equal to cos 3x, therefore, integral of cos 3x with respect to x will be equal to 1 by 3 sin 3x, and that is what we are interested in. An antiderivative, an integral of the following functions by the method of inspection, by simple inspection, right? Using the concept of derivative, that is what we have found. And that's all in this particular second question over here. The third question says we have to solve for antiderivative by inspection once again, and this is e power 2x, okay? How do we handle e power 2x? Now, we remember that e power x, the derivative of e power x is e power x, okay? So, e power 2x, the derivative would also be maybe in terms of e power 2x, yes? So, let's begin with derivative of e power 2x. Oh, but we were supposed to indicate, no, the derivative will also be in that same form, right? In the previous few questions, we began with the derivatives, right? This would be derivative of this, right? Similarly, in the previous question we had cos 3x, which would be the derivative of sin 3x in some kind of form, right? So, we'll begin with this only, and this is equal to e power 2x times derivative of 2x, which is 2. This is what I have. And now I am interested in only this part because I want to find the integral of this, right? So, this 2 will go over here, and this will become 1 by 2 times d by dx, or 1 by 2 can be taken outside, or it can be taken inside. This is 1 by 2 e power 2x, right? 1 by 2 can be taken inside over here, and this is equal to e power 2x, right or not? Yes. And from here I can say that integral of e power 2x, that is the antiderivative of this, is 1 by 2 e power 2x. This is one of the antiderivatives, right? I am not involving any constants of integration over here. The person has asked by the method of inspection, find an antiderivative, right? There is no need of constants of integration, right? So, if you are already aware of the methods, then you could have solved this question directly, but then by the method of inspection, this is the approach that will follow, and that's the solution, that's the answer for this particular question. In the fourth question, we have, okay, once again by inspection, we have to find an antiderivative, and for ax plus b whole square, okay, where can this be brought from, right? Please observe that if this is power 2, then it would be derivative of something called power 3, right? So, we have to begin with derivative of this linear expression ax plus b power 3. Let's begin with this one, right? We'll begin with this one, and what does the derivative of this look like? This is 3 times ax plus b power 2. Okay, this comes here, derivative of this, this comes here, this power 2, and then we need a derivative of this. What is that? This is simply a, right or not? Yes. Once we reach this stage, do you observe that this 3, this a can be brought over here and written in this manner. This is 1 upon 3a d by dx of ax plus b whole power 3, which is equal to ax plus b whole square. Yes, we wanted to separate this and we have separated this. Now we can write the integral, but first let's take care of this 1 by 3a. This 1 by 3a can be brought inside the derivative, right? So this becomes d by dx of 1 by 3a ax plus b power 3, that's the complete thing, is equal to ax plus b power 2. And therefore by inspection, now you can say with the help of inspection you have reached this. If derivative of this is this, then integral of this will be this particular function. Integral of ax plus b square with respect to x will be equal to that ax plus b power 3 upon 3a. That is one of the antiderivatives with respect to this function, right? That's a complete solution for this question number 4th. Next, the fifth question says sin 2x minus 4 into e power 3x. That's what we are interested in. Okay, by inspection, that too by inspection, okay. What about sin 2x? I can handle sin 2x and I can handle e power 3x as well, right? These things can be handled. Okay, so why not handle them separately, right? Why focus on finding the antiderivative of this whole thing, because we know that constants will be playing around one way or the other. So for sine 2x, I look at derivative of cos 2x. What is that? So the derivative of cos x is minus sin x. This becomes minus of sine 2x. The derivative of 2x will be 2. This is equal to this, right? So for integral of sine 2x, I will need to take this minus 2 over here, and this minus 2 will come over here, minus 1 by 2, which can be taken inside the derivative. Minus 1 by 2 cos 2x is equal to sine 2x. This is what I have, right? And this tells me that integral of sine 2x will be equal to, with respect to x, will be equal to minus 1 by 2 cos 2x. This is what you'll have, right? That's one part. What about the other thing? We have, okay, minus 4 e power 3x. That's what we have, right? So we are interested in e power 3x, the derivative of e power 3x, sorry, the integral of e power 3x, and for that we'll have to think, okay, this e power 3x can be obtained by taking derivative of e power 3x, right? So let's begin with d by dx of e power 3x. What is that equal to? E power 3x times 3 is what it is equal to, right? Okay. We are interested in this e power 3x, but along with this we are also interested in minus 4, right? So let's write it in that manner. This becomes 1 by 3 d by dx of e power 3x, which is equal to e power 3x, okay? Now I multiply with minus 4 as well. This is minus 4 times this, and this will become minus 4 times this, right? This is what I get. This minus 4 by 3 can go inside, and what I get is d by dx of minus 4 by 3 e power 3x, okay, and this is equal to minus 4 e power 3x. This is it. This is what it is equal to, right? Okay, once we have written this properly, then we can say that therefore the integral of integral of this expression over here, minus 4 e power 3x dx is equal to this whole function, which is minus 4 by 3 e power 3x. Okay, this is one thing, this is second, and I can take this integral and this integral by adding 1 and 2. What does it give me? This is integral of sine 2x dx plus integral of minus 4 e power 3x dx. This here is equal to what? This is equal to minus 1 by 2 cos 2x, okay, minus 4 by 3 e power 3x. Yes, we can combine these two integrals, and that tells me that sine 2x minus 4 e power 3x, this integral of fx, integral of gx can be done as integral of fx plus gx dx is equal to half with a minus cos 2x minus 4 by 3 e power 3x, and yes, that is one of the antiderivative or integral of this function. That's the required answer for this question, and this is the question that is, we have solved this question by inspection, right? And we have found an antiderivative, right? Don't forget that. We're not using constants of integration yet, and this is fifth question for us. The sixth question says, find the following integrals in exercises 6. Okay, we are supposed to find the integrals over here. Integral of 4 e power 3x plus 1 dx. Now, how do we deal with this one? Now, before I continue any further, I want to tell you a small thing. What is that small thing? Now, this particular thing has been skipped in the NCERT maybe, but I don't know the reason for that. The methods of integration which you study in the second exercise deal with this kind of thing, but then if you know certain formulae, let's say if you know that integral of sine x dx is equal to cos minus cos x plus c, if you know this, then you should also be aware of integral of sine of, instead of x, if you have a linear expression in terms of x. Okay, what is this integral is equal to? This integral is minus of cos, similar thing, ax plus b, okay, and we divide by this a over here. plus constant of integration. This is the integral of this. Mind you, this works only if you have, instead of x, you have a linear expression of x. This can be written, right? So therefore, if integral of fx dx is equal to capital Fx plus c, if you know this, then you should remember that integral of f of ax plus b dx, f of ax plus b dx is equal to capital F ax plus b whole divided by this a over here. This a is the coefficient of x, right? And this formula only works when instead of x you have a linear expression of x. Linear polynomial. This is important, right? Instead of x, if you have a linear polynomial here, then you can substitute. Instead of x, if you have ax plus b, then the integral will be equal to capital F ax plus b upon small a. This is what you need to do, and that is one thing which explicitly is not mentioned, but then we use this particular thing and we can solve so many questions, right? This is very, very useful, and those of you who have studied integration would have studied this thing very initially, right? So I'm explaining this particular thing over here, and now let's begin solving this question, right? So integral I is equal to integral of 4 e power 3x plus 1 dx, right? By the way, that particular expression, this particular result can be included in the initial fundamental theorems, and you can write that down properly and memorize this, right? Use it after that. For solving this, what do I need to do? I can split this and this into two separate integrals. This becomes 4 times e power 3x, and the integral, the 4 will go outside, this is what you'll get, plus integral of 1 dx, which is integral of dx, right? And now the standard formula tells me that integral of e power some linear polynomial would be equal to e power that linear polynomial divided by the coefficient of this x. This is what I'll get, right? This is something which you can obtain by inspection as well. This is something which you can solve by inspection as well, but this is useful. If you know this, then you can write this directly. Plus, what about integral of 1? Integral of 1, standard integral, this is simply x. This was x power 0, it becomes x. Okay, and you write a constant of integration as well. So this actually is 4 by 3 e power 3x plus x plus c, and yes, that is my answer for this question. So simply using inspection also you could have reached this, but if you know this, then in future you will be able to solve many more questions. And yes, this is one of the initial theorems that you should be aware of while studying integration. Therefore, I have dealt with over here. That's 6th question for us, and this is the answer for this particular question. The 7th question says, okay, you have integral of x square times 1 minus 1 upon x square dx. How do you deal with this? Okay, they are product of two functions, but then I can handle this in the manner of, let us say, I can multiply this x square inside, and x square times 1 upon x square will be 1. This is what I get, right? Now I can separate the two integrals, yes. This is integral of x square dx minus integral of 1 dx, which is this, okay. What about x square? Integral of x square will be equal to x power 2 plus 1 upon 2 plus 1 minus integral of 1 is simply x, and you'll have to add a constant of integration over here. The formula that we have used over here is integral x power n dx is equal to x power n plus 1 upon n plus 1 plus constant of integration, provided that n should not be equal to minus 1. N should not be equal to minus 1. This is important, right? This becomes x power 3 over 3 minus x plus c, and yes, that is the answer for this question. X power 3 by 3 minus x plus c. That's the final answer that you need for this 7th question. The 8th question says integral of ax square plus bx plus c. Okay, how do we deal with this one? So this can be split into 3 integrals. Integral of ax square dx plus integral of bx dx plus integral of c dx, And these constants a, b and c, since they are product, they can come outside, and what you'll see is a times integral of x square dx plus b times integral of x dx plus c times integral of dx. Okay. For x square, the integral will be x power 1 higher power 3 upon 3 b times x power 1. The integral will be x power 2 by 2. This is what you will get, right? Plus c times 1, the integral is x. And you will have to add a constant of integration. Constant of integration, since c is already being used, let's use c1. We could have used d as well, but this is constant of integration. That's what you're using. This is a x power 3 by 3 plus b x square by 2 plus cx plus c1, and yes, that is the required answer for this question. That's the final solution for this 8th question. The 9th question says you have to integrate 2x square plus e power x. Okay, and yes, I can write it as 2 times integral of x square dx plus integral of e power x dx. This is what you can observe, right? 2 times integral of x square dx plus integral of e power x. This is 2 times, okay, x square. The integral will be x power 3 upon 3 plus integral of e power x will be simply e power x, and you add a constant over there. That's the answer for this question. Simply 2 by 3 x power 3 plus e power x plus constant of integration. That's the final answer for this 9th question over here. In the 10th question, we have root x minus 1 upon root x. Okay, and it's a square. Okay. So this seems like something squared, but is this something a linear expression? No. So can we apply property? The result like, okay, power x power n equals integral of x power n equals x power n plus 1 upon n plus 1. No, we cannot apply that. For handling this one, what I can do is I can simplify this expression inside the integral. Okay, this is a minus b whole square, that will be equal to a squared plus b squared minus 2ab. This is what you'll have, right? Dx. Once you use this, then what is remaining is this is x plus 1 upon x minus this is simply 2 dx. And now you can integrate this very easily, right? Integral of x dx plus integral of 1 by x dx minus 2 times integral of dx. This is what it will break into, right? What is integral of x? This is x power 2 by 2 plus what is integral of 1 upon x? Okay, integral of 1 upon x is log of mod x. Right? This is something which is a part of the standard formula. What is this? Minus 2 times integral of 1 dx will be x plus a constant of integration, and yes, that is the required answer for this question over here. This is 10th question for us. Question number 11 says that integrate x power 3 minus plus 5x square minus 4 whole divided by x square. How do we deal with this one? We see this x square is creating a problem, but when it is written in this particular form, if you slightly modify it and write it as separate terms, what do you see? This is x power 3 upon x square dx plus 5 times integral of x square upon x square dx minus 4 times integral of 1 upon x square dx. I can write that whole expression as this, right? Do you observe that? X power 3 plus 5x square minus 4 has been split, x square goes to each, and this is what I get. This is integral of x dx plus 5 times integral of dx minus 4 times integral of 1 upon x square dx. This is what I have. Is that okay? Yes. Now integral of x is x power 2 upon 2. X power 1 plus 1 upon 1 plus 1. This is this. Plus 5 times integral of dx is simply x. And minus 4 times, this is actually x power minus 2. X power minus 2, the integral will be minus 2. X power minus 2 plus 1 upon minus 2 plus 1 plus the constant of integration. This is what you get. What does this simplify to? This is x square by 2 plus 5 times x. This is minus 1, which will become plus 4, okay, x power minus 1, which is this, plus constant of integration, and yes, that is the required answer for this question, as you can see over here. In the 12th question, we have x power 3 plus 3x plus 4 whole divided by square root of x. Okay, so once again we can take that root x to each of these terms and simplify those terms, then take the integral, right? So this will be equal to integral of x power 3 upon root x plus 3x upon root x plus 4 upon root x dx. This is x power 3, x power 1 by 2. When we subtract, what do you get? X power 3 minus x power minus 1 by 2, right? So x power 3 minus 1 by 2 is x power 5 by 2 over here. Plus this is 3 times x power 1 minus 1 by 2, which is 1 by 2. Plus 4 times x power minus 1 by 2 is what I have in this integral, right? Now I can separate out these 3 terms, right? And then take their integrals. Now what will be the integral of x power 5 by 2? This will be x power 5 by 2 plus 1, which is 7 by 2 whole divided by 7 by 2. Plus 3 times, this will be x power 3 by 2 upon 3 by 2. You add a 1, right? 4 times x power minus 1 by 2 plus 1 will be plus 1 by 2 plus 1 by 2 upon 1 by 2. This is what you get, right? Minus 1 by 2 will become plus 1 by 2. Why will it become? Because you add a 1, right? That's what you do. Plus the constant of integration. This simplifies to 2 by 7 x power 7 by 2 plus 2 x power 3 by 2, right? There's a 3 and this 3 gets cancelled. This becomes 4 times 2, 8 x power 1 by 2 plus c. That's the answer for this question over here. That's the final answer for this 12th question. 13th question, we have x power 3 minus x square and you have plus x minus 1. In the denominator, you actually have x minus 1. How do we handle this one? So if you observe this x minus 1, what happens is, okay, x minus 1 gets divided by x minus 1. What about this? Okay, this, you can take a x square common over here. And that also gives me x minus 1 remaining. So x square times x minus 1 plus 1 times x minus 1 is what I see over here. Okay, but this is something which you can clearly observe. You can clearly observe in this particular question. In general, always think of, let us say, if you have x minus 1 over here, can you take out a factor of x minus 1 common from here somehow? That is something which you need to apply, right? Divide this by this. That's what you'll do. Some quotient, some remainder. Here the remainder will be simply 0. The quotient will be x square plus 1 times x minus 1. This is a divisor. X minus 1 is also there. Integral dx. You can see this term, this particular term will get cancelled, right, from numerator and denominator. And what will be remaining is x square plus 1 dx. Integral of x square plus 1. Now integral of x square is x power 3 upon 3. Integral of 1 is x plus the constant of integration, and yes, that's the required answer for this question over here. Is that all? Yes. 14th question says we have 1 minus x multiplied by root x. Okay, so what will happen with this root x? This is in product. We'll have to multiply this together, and what does this give me? This gives me root x minus x root x dx. I can integrate this, but first let's write them in the form x power n. So integral of x power 1 by 2 minus x power 1 and 1 by 2 will be added to 3 by 2 dx. Okay. Now integrate x power 1 by 2 will be equal to x power 3 by 2 upon 3 by 2 minus the integral of x power 3 by 2 will be x power 3 by 2 plus 1, which is 5 by 2 and 5 by 2 in the denominator, plus the constant of integration. This is what you get, right? So this term will be equal to 2 by 3 x power 3 by 2 minus 2 by 5 x power 5 by 2 plus c. This is the final answer for this question, as you can see over here. The 15th question, we have root x times 3x square plus 2x plus 3 dx. Okay, let's multiply by that root x inside. So this becomes integral of 3 x square root x. Now power 2 power 1 by 2, they will add to power 5 by 2 plus 2 times power 1 by 2 will be power 3 by 2 plus 3 times root x, which is x power 1 by 2 dx. This is what I'll get, right? I can separate out the terms and see where does that take me. This is 3 times integral of x power 5 by 2. What is integral of x power 5 by 2? This is x power 7 by 2 upon 7 by 2 plus, okay, this is 2 times x power 3 by 2. This is not 2 power 3 by 2. This converts to 2 times x power 3 by 2. X power 1 by 2, x power 3 by 2, and this will further convert to 2 times, okay, x power 3 by 2, the integral will be x power 3 by 2 plus 1, which is x power 5 by 2. In the denominator you will have this 5 by 2 only. 3 is okay, x power 1 by 2 will integrate to x power 3 by 2 upon 3 by 2 plus a constant of integration. This is what I get, right? The 7 by 2 will convert to 2 by 7 in the numerator. This is 6 by 7 x power 7 by 2 plus, this is 4 by 5 x power 5 by 2 plus, this is 2 x power 3 by 2 plus c plus the constant of integration, and that's the answer for this question, as you can see. In 16th question, we have 2x minus 3 cos x plus e power x. Okay, different types of functions. Within each of them is very simple, right? 2 times integral of x dx minus 3 times integral of cos x dx plus integral of e power x dx. We can separate this into 3 different integrals in this manner. 2 times integral of x will be x power 2 by 2 minus 3 times. Integral of cos x is simply sin x plus integral of e power x is e power x, the constant of integration after that, and this simplifies to x square minus 3 sin x plus e power x plus c. That's the required answer for this question, question number 16th. In 17th question, we have 2x square minus 3 sin x plus 5 root x. Once again, we have sin x, different types of functions. So, it can be split as 2 times x square dx minus 3 times integral of sin x dx plus 5 times integral of square root of x dx. This is what we have. Okay. Integral of x square is x power 3 upon 3. Okay. Minus 3 is okay. Integral of sin x is minus cos x plus 5 is okay. Integral of root x, that is x power 1 by 2, will be x power 3 by 2 upon 3 by 2 plus the constant of integration. This is what you have, right? This simplifies to this plus 3 cos x, and this becomes 10 by 3. X power 3 by 2 plus constant of integration. That's the final answer for this question, as you can see over here. Yes. Next. The 18th question says we have sec x times sec x plus tan x, and how do we handle this one? Okay. So, related to sec x and tan x, we have 2 results. Integral of sec square x dx is tan x plus c, and integral of sec x times tan x dx is equal to sec x plus c. Since derivative of sec x is sec x plus tan x, therefore this. So, in this question, you observe that you are actually seeing a sec square x plus sec x times tan x dx by multiplying by that sec x inside, right? Now, these can be separated into 2 different integrals. This is sec square x dx plus integral of sec x times tan x dx. This is what you have. Now, what is integral of sec square x? This is tan x. What is integral of sec x tan x? That is sec x plus a constant of integration. So, the final answer is tan x plus sec x plus c that's the answer for this particular question over here. These are the results that we have used. In the 19th question, we have sec square x upon cosec square x. Now, how do we handle this one? Okay, sec square x and cosec square x. At max, what we can do is we can write them in terms of sine and cos. Yes. So let's try to simplify this. This is 1 upon cos square x. Sec square x is 1 upon cos square x. Cosec square x is, in the denominator you have 1, and denominator sine square x will come over here. This is what you have. What is this converted to? Do you see that sine square upon cos square is actually tan square x? But do we know the integral of tan square x? No, we don't know the integral of tan square x. What do we know the integral of? We know the integral of sec square x. So tan square x can also be written as, using trigonometric results, this can be written as this. 1 plus tan square x is sec square x, therefore sec square x minus 1 is also tan square x. And integral of sec square x is tan x minus integral of 1 is x plus constant of integration. This is the required answer for this particular question over here. That's the 19th question for us. In the 20th question, we have 2 minus 3 sin x whole divided by cos square x. Now, how do we handle this one? Okay. So, once again, this cos square x can be divided by each of these, right? And what do we have? 2 upon cos square x minus 3 sin x upon cos square x. Now, look at these two expressions carefully. 1 upon cos square x can be written as sec square x. So, this becomes 2 sec square x. And we know the integral of sec square x, right? Sin x and sec square x, is it? No, we don't know that. But do you see that sin upon one cos x term will be tan x and another cos x will be converted to sec x. So, this is 3 times. And we know the integral of each of these, right? So, now we can integrate them. 2 times the integral of sec square x is tan x minus 3 times integral of sec x tan x is sec x plus a constant of integration, and that is the required answer for this question, as you can see over here. This 20th question for us. In 21, the person says, okay, the antiderivative of this equals which of these? There are 4 options, right? MCQs. Okay, antiderivative means the integral of this, right? And what will be the integral of square root of x? That will be, this is x power 1 by 2. So, the antiderivative will be x power 3 by 2 upon 3 by 2. The antiderivative of the second term, that is x power minus 1 by 2, will be x power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. Okay, there is a plus sign in between. This is what you get. Or it simplifies to 2 by 3 x power 3 by 2. This is 1 by 2. It goes at the top. This becomes this. X power 1 by 2 is what I get. Plus a constant of integration as well. Yes, that's what you need. So that's the antiderivative of this, and which of these options is correct? You need x power 3 by 2. Okay, this is x power 2 by 3, does not work. X power 3 by 2, but you need a 2 by 3 here as well. This does not work. Okay, you don't need 1 by 3, you need 2 by 3 x power 3 by 2, 2 by 3 x power 3 by 2 plus 2 x power 1 by 2 plus c. Okay, the correct answer is option C. For this question, the correct answer is option C, as you can see with the calculations, right? That's all in this question. The 22nd question says, okay, if d by dx of fx equal to 4x power 3 minus 3 upon x power 4 such that f2 is equal to 0, then fx. Okay, so we begin with this. D by dx of fx is equal to minus 3 upon x power 4. Okay. So, can we say that fx will be nothing but the integral of this expression, x power minus 4, is it, dx, right? This is what you have. So, fx is the integral of this. Can we find the integral of this? Yes. This is 4 times integral of x power 3 is x power 4 upon 4 minus 3 times integral of x power minus 4. So, that will be x power minus 4 plus 1 upon minus 4 plus 1, x power n plus 1 upon n plus 1. Plus a constant of integration, right? So, this becomes x power 4. This is minus 3 will become plus x power minus 3 plus c. It can be written as x power 4 plus 1 upon x power 3 plus c. Okay. What next? What next? So we have found the particular form in which the integral will be obtained. X power 4 plus 1 upon x power 3. Yes, this or this. No, this is not correct. This is not done. This is not done. But either this or this. Now 129 upon 8 or minus 129 upon 8, which of these will be correct? There should be extra condition. Yes, there is an extra condition for that. F2 is equal to 0. With that extra condition, you can find the constant of integration. So let's do that. Implies that 2 power 4 plus 1 upon 2 power 3 plus c is equal to 0. Which tells me c is equal to minus of 2 power 4 minus 1 upon 2 power 3. What does that tell me? This is minus 2 power 7 plus 1. If you take minus common, this is what you get. In the denominator, you have 2 power 3. This is what you get. Right or not? Yes. And 2 power 7 is 128. This is minus 129 upon 8. The value of c has been found as minus 129 upon 8. That c can be substituted over here to get the exact value of exact fx, which satisfies this. So minus 129 by 8, the correct answer is option A for this particular question, as you can see with these calculations over here. First we find fx, then we use the condition given to get the value of c, and yes, substitute that value of c to get the final answer in this question as written and explained over here. So that's all in this question. And with this, we also come to the conclusion of this complete exercise based on exercise number 7.1, which was based on the basic formulae and some basic concepts of integration, right? Till the next session, all the best. We'll see you again in the next session.